Hello everyone, my name is George and I am Endurance Robots founder. Tonight I'm going to tell you my thoughts about space, universe, and how we all appear. I'm actually very delighted to what Elon Musk is doing, trying to make flights to space affordable. I think it's a really cool idea because it'll bring us to a new step of evolution. We will not just fly to space, we will learn more about it. So, and also I was happy to hear that Yuri Milner and Stephen Hawking, they are going to make a small robot and send it to Alpha Centauri, and it will reach about in about 20 years. So they're going to get about 20% of light speed just beaming the laser on this small robot. It's kind of fun. Don't worry, it's an ice from ice machine. So what I was going to tell you and share uh, a lot of things that really concern me, and I try to find solutions by doing robots and working in a high-tech industry, but also reading a lot of interesting information in Wikipedia, different sources, watching different science channels like Discovery, and also a lot of different movies on YouTube where you can find about our humanity and where we go to and what we actually did in the past. So the biggest question I would like to start with is what is matter? I mean, what is a dark matter? I mean, a lot of scientists, they keep saying that there are a lot of dark matter surrounding us, like 30% of all universe consists of dark matter. But isn't that ridiculous that no one even saw it? And what is dark matter? Is it matter with a negative spin and positive mass, or negative mass that influences gravity? They can only tell uh, about matter by analyzing gravity in the world. So this is a big trick. So no one even understands how dark matter should look like and what is actually what characteristic features should be. So another thing that is a big question for me about the Big Bang. So a lot of scientists say that it was a Big Bang and it came from very stable point in the universe. But no one says where this point actually was, and where is the place in the universe where this Big Bang started. So it doesn't seem right when you tell about time space and you tell about the universe that it has time 13.6 billion years ago, but no one's saying where exactly it occurred. And another question, if it was so stable for unlimited period of time, why it became so unstable later? So this is a big question. And then we learn from scientists to say that by that time, matter appeared, and there is a symmetry theory that says that matter appeared in two parts, like matter what we have and antimatter. But why then everything is formed out of matter, and no one's seeing this antimatter? Or is dark matter is an antimatter? We don't know. So there are a lot of different things that are under consideration. Like I said, is why we don't see antimatter so much as we see matter, or if so, then it means that the symmetry theory is probably not that correct. Another unknown thing in modern physics is, are all constants like speed light, really constant. So if we take speed light 300,000 kilometers per second, we assume that this is a constant speed in vacuum. But we do not know, was it always that constant? Or was it more or less when the universe was actually born? The same question I asked about gravitation. So if gravity constant still the same, another thing that's also unknown, quite unknown, why this constant appeared the same value, so the gravity value or a speed light value. So in this time you probably know that many groups of scientists, they try to measure this gravity value by making different or same experiments. So what I actually don't understand that why every time they measure this gravity constant, it's always different. It's never been the same. As they make more and more experiments, then they understand that all the time it's absolutely different. I don't know why it happens. So we just started with the basic things of the universe, how it appeared. Now I would like to go back to solar system, to where we live, where we are. So if we take all our planets and we try to find out the range between Sun and their orbits, it has to follow and meet with Johannes Kepler, the oldest, probably one of the oldest astrophysics laws. So the planet has to be in the same, in a different range to where Sun is. So there is a special law, and actually it happened how Uranus and Neptune was actually discovered by knowing this law. But no one can explain why is it so. Why this law has these constants. So not many theories can explain it. So and there is no complete theory explaining the origin of solar system. Okay, let's imagine that solar system appeared after explosion of supernova or other star in our galaxy. That that actually created different materials and like metals, oxygen, and different rare materials and like thorium, titanium, different heavy parts and heavy particles. But then it doesn't make sense how Sun appeared. I mean, if some planet, if some star like supernova exploded like billions years ago, like let's imagine 10 billion years ago, and then this mass of gas was fluctuating all over our galaxy, that doesn't make sense how our Sun appeared. It means that our Sun appeared with the rest of material, but then it doesn't really make sense why so many hydrogen on our Sun, because supernovas, they explode when they are out of actually hydrogen or helium. But look at Sun, it has a lot of hydrogen, and some planets, they have hydrogen as well. So it doesn't make really good sense how our solar system appeared. I also tried to find out, so it's hard to explain about exoplanets as well. So what I think that the biggest question is, if this supernova explode and brought these all particles together, so how actually Sun appeared? We used to know that it came from protoplanet and it's under the gravity. It appeared and got together, and these more and more particles, gravity got it, and then Sun burned. but it's also a big question if it's true or not. Another thing that I'm going to tell about sun, and actually that poses more questions than answers, that why solar corona has higher temperature than sun surface or sun photosphere. So sun corona has about 5, 10 or even 20 million Kelvin degree, while the photosphere and the surface of the sun has only 5,000 Kelvin degree. Doesn't make sense how this temperature increasing, in a corona. Why it's increasing? It should be, it should be vice versa. The core of the sun should be very, very hot, not just corona. Corona should be very, very cold in terms of thermodynamic laws. And another question regarding sun, why magnetic field is changing, why it's not stable. So every 11 years we see that completely different things happen on the sun. So we have changes of magnetic field of the sun. It doesn't seem right. I mean, why does it happen? No one's explaining this. And like I said, the mechanism before why supernovas explode. So still we have no theories why does it happen. I mean, we understand that they are lack of hydrogen and they use helium by the time they are out of matter to keep burning, but still we don't understand why they just don't burn out, they just explode. This is a big question. Another thing I'm going to tell about our solar system, not very much related to sun, but solar system in general. So we used to know that Earth has a big magnetic field, and some scientists say that because of metallic core of the Earth. But look at Mercury. It has the most massive metal core out of all planets, and it has the highest speed of moving around the sun, like 33 kilometers per second, if I'm not mistaken. But it has no atmosphere or magnetic field, and it's a big question why. And just after 50 million kilometers away from Mercury to Earth, we have Venus that has one of the strongest atmosphere in our solar system. We don't understand why, and it is so strong that we couldn't even survive there. So it has the highest temperature on its surface, and we still don't understand why it doesn't have so powerful magnetic field like Jupiter, but still it can get a very high density atmosphere. Another thing that's actually not quite clear for me is why. Okay, we have the theory that Moon appeared after a big object like Mars hit our planet. We don't know what was the name of this planet or this object. It could be a comet or asteroid. We don't know it, or a massive big planet. But there is a theory that actually something hit the Earth and our Moon appeared. Then I have a question: why Moon is not the same as Earth? Yes, it's smaller, but it has no atmosphere at all. I mean, if it's like the same part of the Earth, it should be quite the same as Earth. Maybe a little bit smaller, maybe having like 1% of 5 or 10% of Earth's atmosphere on its surface, but it has none. It's like on Mercury, it has nothing. And we don't understand exactly why it happened. So it's also the question how Moon appeared, if it's true that something hit Earth and Moon appeared, or we don't really know. So what I'm going to tell you another question that uh, many scientists keep saying that they understand these uh, power, these forces that influences on Earth and the Moon. So that's why we have these waves on Earth when we have a gravity impact from the Moon. But the question is that it's not really true. I mean, we cannot predict the height of a water, of a sea level, knowing the position of the Moon. So it does not really reflecting the 100% correlation between the position on the Moon against the Earth and the sea level. So it's still a big question. So another big question in astrophysics is why Jupiter and Saturn are located so far away from the Sun. As far as some of you probably know, that the most common exoplanets are called hot Jupiters. So Jupiters and big planets like gas giants, they used to appear near the star where they have enough of left hydrogen and helium after star burn. But in our system we have like 700,000 kilometers from Sun where actually Jupiter is, and twice further from Jupiter is Saturn. It's also gas giant. Well, it seems to be, not quite right according to the theory that, from the disk, the rest of matter was used for forming big planets. So it's also a big question why they form so far away. Another question is why Jupiter has so high speed of rotation around its axis. We still don't know, and we don't have an answer why the speed is so high. Another question that is unsolved, probably you all know, about rings of Saturn. How they appeared, how they formed, why they're so thin, like a couple meters only, and still no answers. The answer that something like a planet hit it is also not quite, right, because there are different rings around Saturn. We still don't know. Back to Jupiter, I wanted to say that the big question about red spots. No one has an idea what's inside this red spot, and how come that for 300 or 400 years this red spot, big storm, is still there. I probably would pay another attention that back to further from our solar system, to outside. We go to Uranus, and we understand that its light lays on its side, so it means that it's rotating around his axis, lying on a side that the only planet does. We don't know why it happened. Was it from the very beginning of when it was formed, or it happened later? Then we have Neptune, that has the strongest winds in our solar system. So it is very cold there. It's like only minus 240 degrees Celsius. It's really cold there, and we have the strongest winds. I mean, we understand probably if we look into Jupiter that heat from the center goes to the upper part of atmosphere, and it creates these blows. But what happened Neptune. It's a smaller planet. It has no metallic hydrogen. It has something else. We also don't know what's inside the core of Neptune and Uranus, because if you take Jupiter and Saturn, they're very similar. But if you have a look at Uranus and Neptune, they are similar to themselves, but not to Saturn or Jupiter. So it's a big question how they were formed and what is the big difference between them. And I would also wanted to put your attention that the magnetic field of Neptune and Uranus, it's not the same as a polar like they're poles, so they are not the same. So northern pole and southern are not the same as magnetic poles. We also don't know why. It's actually another intriguing. Okay, okay, another question. Another question we don't understand is why we have so many differences in these giants. And I would say that another thing that is not quite common for me is why some smaller planets like Pluto has 5 satellites. Look, Earth has only 1, Mars 2, Venus 0, and Mercury also 0. But if you go back further and you look at Pluto, it has 5 satellites. The smallest planet, it's not called actually a planet now, but it used to be a planet, has 5 satellites. We don't understand why it happened. So also telling about the Venus, no one's actually knowing why the rotation of Venus around its own axis has so small speed. We don't know. It has to be faster. It has to move faster, but in fact, it's not that fast. So yeah, I was trying to say about Saturn that these rings, no one's getting an idea how they appeared, but if you look on Uranus or Neptune, they have rings too. They're not so big, but they have them. So a lot of questions that still have to find their answers about our universe. But I want to ask you, why our universe is still expanding? I mean, if it's still keeping its momentum after exploding, after the Big Bang, it's still moving and expanding. But according to Hubble, who said that the expanding is increasing, we don't have an answer. What's going to be next? How our universe should die or should end? Should it be a big gap or a big crunch? We don't know what will happen. Absolutely no ideas. Sometimes after watching different movies, I understand that Lars von Trier, from his movie Melancholy, was sometimes right when he said that the life on Earth was a contingency. We don't understand why it appeared and where it will go. But the interesting thing that we understand that the universe will die one day. If it's appeared, it will not die if it never appeared. Everything that has beginning has its end, and we still don't know what's going to be in the nearest future. So that's pretty much it I wanted to share with you about my thoughts and about the idea of universe and global things. And probably the last thing I was going to tell you about black holes. You know that no one ever saw them yet. So the only thing that you can calculate a black hole is by analyzing the movement of stars around the center of the universe, of the galaxy, sorry, of the universe, around the galaxy. So if you have a look at the center of our Milky Way, you see that stars are actually moving, following different orbits, but no, and scientists keep saying that it should be a supermassive black hole, but no one saw it. Yeah, I understand you cannot see it because it's black and even light cannot go out of it. Then another question, if you get inside a black hole, let's imagine it can, what happens with time there? Do you have time there? According to a special theory, well, not special, just I don't know how to say it in English. Find it. General theory of relativity, that you can be inside of a black hole and having it called a wormhole. We don't know what happens with time there. Is time the same as here, or it stops? Another question, what happens with information? So let's imagine that with the light that is captured by the black hole, there's some information could be caught by a black hole. Do you have an idea what happened with the information there? Is it destructed, or if it's still there, what happens with it when black hole burns? We know Stephen Hawking proved in his theory that some rays, it burns, black hole burns in the time. We don't know what happens with an information that is hidden inside. So I try to figure it out what happens with an information and what happens with the universe after everything collapsed in the same position where it was from the very beginning, from the Big Bang. So we have no ideas what's going to happen to us and how the universe will finish its life. Should it be like billions of black holes, or one at the end, or another singularity spot like it was from the very beginning? We don't know. I have no ideas. So modern physics is actually is not answering a lot of questions. It has more questions than answers. And I would say that in quantum mechanics, it's even hard to understand what's inside the atoms, what's inside subatomic particles. No one can even understand what it's about, how it looks like. Well, most of quantum mechanics and quantum physics is like huge amount of numbers, and if you have a look in collider, people hardly understand the process. They can understand by analyzing numbers they got after colliding different particles. So more answers than a question we have for now. That was my channel. I wanted to share with you. Hope that you join me. If you like it, please put like, and talk to you soon. Bye bye.